This lesson is on variables and expressions. What is a variable? We know that a variable is a letter that represents a value we don't know. And a value is another word for a number. Any number that is unknown. An example of that would be x is what we most commonly use. And a value that we don't know the answer to, or we don't know that number, is how about the number of grains of sand? Nobody knows exactly how many grains of sand are on this earth. An unknown value. We use y. We also use A, B, C. Any of those letters would work. So now let's talk about what an expression is. And we're not talking about equations yet, but we're looking at expressions. An expression is a combination of numbers variables and operations. Now, we know our four major operations are adding, subtracting, multiplying, and dividing. That's what we're talking about. Okay? So, let's write an example of an expression with one variable. 5x plus 3. An expression. No equal sign, so it is an expression. Write an example of an expression with two variables. How about 2x? Let's do minus 3y. Okay? Two different variables and still no equal sign, so that does make it an expression. All right, so now we're going to look down here at the bottom. Substitute the values from the table into your expression with one variable. Well, you go back to this first expression that we had. We said it was 5x plus 3. Our variable was x. So now let's substitute. 5 times negative 3 plus 3. 5 times negative 3 is negative 15 plus 3 is negative 12. 5 times 0 is the value I'm substituting in, plus 3. 5 times 0 is 0, plus 3 is 3. And plug in 5 for my variable. 5 times 5 is 25, plus 3 is 28. All right, now let's look at the other one, that other example that we did. We had two variables then, x and y. 2x minus 3y is my expression. Now let's substitute. 2 times negative 3 minus 3 times 1. Okay? 2 times negative 3 is negative 6. We can also substitute this into the calculator. So we have negative 6 minus 3 times 1 is 3. So negative 6 minus 3 more is negative 9. The next problem, or the next part, 2 times 0 minus 3 times 2. 2 times 0 is 0. So we have negative 3 times 2 is negative 6. 2 times 5 minus 3 times negative 4. 2 times 5 is 10. Minus 3 times negative 4 is negative 12. So I have a minus and negative, which is just the same thing as plus a positive, which is 22. Now what we're going to do is glue this top and flip up. and we're going to do 2 other examples. All right, let's look at if x is 5 and y is 2, let's solve x squared plus x minus 12 divided by y squared. Lots of order of operations here. Okay? But our overarching goal is we need to know that we have to substitute in for those variables. Okay? So, not x squared, I'm putting in 5 squared plus not x, I'm substituting in 5 minus 12 divided by, take out this variable, put in 2 squared. Okay, so we have 5 squared is 25. We're following our order of operations, our PEMDAS. If you don't remember, we can write it out to the side. Remember, multiplication and division, it's left to right, whatever comes first. Same with addition and subtraction. So then I'm going to just bring this down, plus 5 minus 12 divided by, because I have another exponent here, 2 squared is 4. I don't have multiplication. There's a division, so left to right, 25 plus 5 minus 12. Oh, excuse me, nope, that's not right. 12 divided by 4 is 3. Me getting ahead of myself. Okay. And then addition, subtraction, left to right. 25 plus 5 is 30. Minus 3 is 27. Okay. Let's do another example. Let's do x, y, and we'll square all that. And we're going to do divided by xy. Okay, we're still going to use these values. So let's substitute in for our variables. We're going to have 5, and now x and y sitting next to each other does mean multiplication, so 5 times 2, squaring that whole thing, divided by, oh, there's 5 times 2. Okay, so we need to do what's inside the parentheses first. That's our P from PEMDAS. So we have 10 squared and then divided by 10. Okay, 10 squared is 100, divided by 10 is 10. Perfect. Okay, the next thing we're going to do is work on this foldable here. You just fold everything into the middle and cut the flaps, and it's going to end up going down here at the bottom. Okay, we're going to kind of pick up the pace of the video since we're a little bit running out of time. We should be fine if we keep moving. All right, so we're looking here, when we're writing expressions, we need words that tell us, those operation words, what are we actually going to be doing, okay? So we're going to look at some division, multiplication, addition, and subtraction words. Okay, so some division words or phrases, we know when something says divided by or quotient, how many times, everyone gets this one mixed up. They think the word times means multiply, but how many times does something go into something? It's a division. If you're looking at groups, and each group gets something, or sharing, splitting, split, goes into each, if each person gets something. We know that we can have a division bar for symbols, or that line, that slash line looking like a fraction, or the traditional division sign. Okay. For multiplication, we have product times squared, multiple, twice, means multiplied by 2, double, cubed, means times itself 3 times, per, of, okay, and our symbols. Sometimes we have one of those asterisks, the dot, the traditional. If there's something on the outside of parentheses, that means multiplication, or something is raised to a power. We know it's going to be multiplying by itself that number of times. Okay? Let's look at some subtraction words. We know the symbol, take away. Oh, and there's a phrase, take away. Or fewer, minus, withdraw, loss. Oh, I can't really see that, sorry. Difference, spent, less than, and any others. Oh, decreased is a good one. Okay. And then lastly, let's do addition, sum, add, or sometimes the word problems say added to, increased by, combine, gained, plus, together, in all. I mean, the list goes on and on. And a lot of times. Okay. And now this foldable is going to get glued down here at the bottom of this page underneath your top sheet. Okay. So we're going to do on the left page here, we're going to do some got it questions. So let's see if you got it. Okay. Let's say that A equals 3 and B equals 4. Okay. And problem 1, 3B minus A squared. And problem 2 will be 2B squared minus 7A. I'd like for you to try this yourself. Pause the video if you need to, and then unpause me so you can see me working it out to see if you did it correctly. So let's substitute in. 3 times B is 4 minus 3, and then we have it squared. Exponents first, so 3 times 4 minus 3 squared is 9. 4 times 3 is 12, minus 9 is 3. Okay. And then problem 2, substituting in for B, so 2 times, we're going to have 4 squared minus 7 times A is 3. Substituting in. Exponents first. Square 4, 4 squared. It does not say this times this first. You got to follow PEMDAS, follow those order of operations. 4 squared, that's 4 times 4 is 16. Minus 7 times 3. All right, 2 times 16 is 32. Minus, and then 7 times 3 is 21. And subtract 32 minus 21 is 11.